By definition, two lines, or segments, or rays, are perpendicular if they meet to form congruent adjacent angles. Using this definition, we prove the theorem stating that perpendicular lines meet to form right angles. We can also say that two rays or line segments are perpendicular if they are parts of perpendicular lines. We now consider a method for constructing a line perpendicular to a given line. Construction 6. To construct the line that is perpendicular to a given line from a point not on the given line. Given, in Figure 2.1a, line L and point P not on line L. Construct line PQ perpendicular to line L. Construction, Figure 2.1b. With P as the center, open the compass to a length great enough to intersect line L in 2 points, A and B. In Figure 2.1c, with A and B as centers, mark off arcs of equal radii, using the same compass opening, to intersect at a point Q as shown. Draw a line PQ to complete the desired line. In this construction, angle PRB and angle PRA are right angles. Greater accuracy is achieved if the arcs drawn from point A and B intersect on the opposite side of line L from point P. Theorem 2.1.1. From a point not on a given line, there is exactly one line perpendicular to the given line. The term perpendicular includes line-ray, line-plane, and plane-plane relationships. The drawings in Figure 2.2 indicate two perpendicular lines, a line perpendicular to a plane, and two perpendicular planes. In Figure 2.1c, line RP is perpendicular to line L. The word parallel can also be used to describe relationships among lines and planes. However, parallel lines must lie in the same plane, as the following definition emphasizes. Definition: parallel lines are lines in the same plane that do not intersect. More generally, two lines in a plane, a line and a plane, or two planes are parallel if they do not intersect. See Figure 2.3. Figure 2.3 illustrates possible applications of the word parallel. In Figure 2.4, two parallel planes, M and N, are both intersected by a third plane, G. How must the lines of intersection A and B be related? In this geometry, a plane is a flat, two-dimensional surface in which the line segment joining any 2 points of the plane lies entirely within the plane. Whereas the postulate that follows characterizes Euclidean geometry, the perspective on application section near the end of this chapter discusses alternative geometries. Postulate 10, the Euclidean parallel postulate, is easy to accept because of the way we perceive a plane. Postulate 10, parallel postulate. Through a point not on a line, exactly one line is parallel to the given line. Consider Figure 2.5, in which line M and point P, with P not on M, both lie in plane R. It seems reasonable that exactly one line can be drawn through P parallel to line M. A transversal is a line that intersects two or more other lines at distinct points. All of the lines lie in the same plane. In Figure 2.6, T is a transversal for lines R and S. Angles that are formed between R and S are interior angles. Those outside R and S are exterior angles. Relative to Figure 2.6, we have interior angles, angle 3, angle 4, angle 5, angle 6. Exterior angles, angle 1, angle 2, angle 7, angle 8. Consider the angles in Figure 2.6 that are formed when lines are cut by a transversal. Two angles that lie in the same relative positions, such as above and left, are called corresponding angles for these lines. In Figure 2.6, angle 1 and angle 5 are corresponding angles. Each angle is above the line and to the left of the transversal that together form the angle. As shown in Figure 2.6, we have corresponding angles, which must be in pairs, angle 1 and angle 5 above left, angle 3 and angle 7 below left, angle 2 and angle 6 above right, angle 4 and angle 8 below right. Two interior angles that have different vertices and lie on opposite sides of the transversal are alternate interior angles. Two exterior angles that have different vertices and lie on opposite sides of the transversal are alternative exterior angles. Both types of alternative angles must occur in pairs. In Figure 2.6 we have alternate interior angles, angle 3 and angle 6, angle 4 and angle 5. Alternate exterior angles, angle 1 and angle 8, angle 2 and angle 7. In Figure 2.7, parallel lines L and M are cut by transversal V. If a protractor were used to measure angle 1 and angle 5, these corresponding angles would be found to have equal measures, that is, they are congruent. Similarly, any pair of corresponding angles will be congruent as long as line L is parallel to line M. Postulate 11. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. In Figure 2.7, line L is parallel to line M, and the measure of angle 1 equals 117 degrees. Find A. Measure of angle 2, B. Measure of angle 5, C. Measure of angle 4, D. Measure of angle 8. Solution. A. Measure of angle 2 equals 63 degrees. It's supplementary to angle 1. B. Measure of angle 5 equals 117 degrees, corresponding to angle 1. C. Measure of angle 4 equals 117 degrees. It's vertical to angle 1. D. Measure of angle 8 equals 117 degrees, corresponding to angle 4, found in Part C. Theorem 2.1.2. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Theorem 2.1.3. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. When two parallel lines are cut by a transversal, it can be shown that the two interior angles on the same side of the transversal are supplementary. A similar claim can be made for the pair of exterior angles on the same side of the transversal. Theorem 2.1.4. If two parallel lines are cut by a transversal, then the interior angles on the same side of the transversal are supplementary. Theorem 2.1.5. If two parallel lines are cut by a transversal, then the exterior angles on the same side of the transversal are supplementary. Given line TV parallel to line WY with transversal line RS. Measure of angle RUV equals the quantity x plus 4 times the quantity x minus 3. Measure of angle WXS equals x squared minus 3. Find x. Solution. Angle RUV and angle WXS are alternate exterior angles, so they are congruent. Then, measure of angle RUV is equal to the measure of angle WXS. Therefore, quantity x plus 4 times the quantity x minus 3 equals x squared minus 3. Solve for x. X squared plus x minus 12 equals x squared minus 3. FOIL on the left. X minus 12 equals negative 3. Subtracting x squared from both sides. X equals 9. Add 12 to both sides. Note, both angles measure 78 degrees when x equals 9.